Hello, this is Octavio Menocal, and I'm going to explain a project that I've been working on. It's a backend application hosted in AWS, written in Typescript, and with additional features like environment deployments with GitHub Actions, TSLint roles, and unit tests and integration tests. The use case is a hotel reservation API with 5 operations: create, update, delete, and get a reservation, and also get all reservations in the system. So let's get started. We'll be looking at the serverless.yaml file, all the configurations I have set up for this little application. First of all, the service is called Hotel Reservation API. We will be working with the version 3 of the framework. I have set up some custom parameters for the different environments. We'll be working with 3 environments: development, staging, and production. Um, in this case, we have some configurations for the API gateway quota, DynamoDB capacity units, Lambda memory size. Also, we have the configuration for some plugins I have installed. In this case, the sbuild plugin for the packaging for the Lambda functions, and DynamoDB local to run while I was developing, to run the tasks locally. And finally, the prune plugin to delete older Lambda versions. I only want to keep the 3 last versions of my Lambda functions. We'll be working with Node.js 16, some environment variables that we will use, in this case, mainly the reservation table, the DynamoDB table. For packaging, I want to pack my Lambda code individually, and I want to exclude the development dependencies. At the beginning, I only had one Lambda function, the create reservation Lambda function, and all the configuration of that function was here. But as I kept adding more functions, I decided to split the code of these functions in different files that we'll check later on. So right now, I simply define the 5 Lambda functions here, and the configuration for every of them is in their own file. For the resources, since I only have one DynamoDB table, I decided to keep it here with the reservation ID as the main, the hash key. And capacity units, well, for some environments that are for internal use, for example, development or staging, I don't want to use a lot of capacity units, so you can see that I have customized those values per environment here, just one capacity unit. And for production, I have 5. This will help increase the speed for operations, for DynamoDB operations. And the last part of the serverless file is the definition of the plugins that I'm using. All right. In the root directory, there are another interesting files here. For example, the TSLint rules that I want to define for my project. These are full customized, and this will help me keep my code cleaner. The tsconfig JSON and the tsconfig path will also help me in for that. I also have configuration for the jest unit tests that we'll see later on. Okay, let's get started and review the source code of this project. For the functions inside the source folder, we have create, delete, get all, and update. Every folder has 2 files: the handler, which is the entry point of the function, and the definition of the Lambda configuration for this function inside the index.yaml file. Uh, all the Lambda functions have the same similar configuration. Of course, it changes the name, the description, uh, the IAM role permissions change as I wanted to respect the least privilege principle for IAM permissions. So, for example, the delete function is the only one that has the permission to delete an item inside the reservations table or the DynamoDB table. All of them are exposed via a REST API gateway endpoint, and uses each of them use their own HTTP method to call the endpoint. For example, this is the delete function uses the delete HTTP request. Let's take a look at the create reservation code. It uses the Typescript syntax. I created a reservation type for this project, which is in the model folder with very basic attributes. I just wanted to have a reservation ID, the room ID, the client ID, start and end date, and of course the created date for this record in the table. All the operations are performed inside one service class, which is the only one that has access to the AWS SDK package. In the reservation service, inside the service folder, are all the methods required by these functions. We made use of async await pattern, and we use promises a lot. In this case, we simply call the document client object from DynamoDB to perform all the put, get, scan, update, here's the update, and the delete operation. As I told you, all of the Lambda functions have their own IAM role permissions and endpoints specified inside the events HTTP API property. In the model, we have a helper function to get a DynamoDB document client. In this case, since I was developing locally, I wanted to have a local endpoint that points to localhost, and when we deploy to AWS, we use the AWS endpoint. So this is all the source folder. It's pretty straightforward, no more business rules, just a simple call to the DynamoDB table to perform the operations we care about in this case. We also have the tests folder for unit and integration tests. I'm going to show you real quickly about what test and how the test look, and how we mock some packages. In this case, this is a test for the create reservation function. We call our handler, our create handler, and we pass some parameters that we already know, and we want to compare the output of this function by not only mocking the UUID for creating the reservation ID, but also the AWS SDK document client object, so that we don't perform actual, in this case, put operation to any database, because this is just test. In this case, the reservation ID we expected, the output is what we expect, and we're going to review that, the output, when we deploy to our GitHub repository. That's the next thing I wanted to show you, the configuration of the workflows for the GitHub actions. Uh, I have one continuous integration workflow for checking the lint rules and the unit testing. I only check the unit testing for continuous integration. This is only performed on a pull request to the dev branch. So the model that I'm following is that I have in the repository a dev, staging, and master branch, but all the changes that I make for fixes or new features are pushed uh, from another branch that I work. And then I create a pull request to the dev branch. That way, when I create a pull request, the continuous integration workflow gets triggered. And the first thing it does is to check lint rules and testing, the unit testing. So in this case, I'm going to, I don't have any changes here. I'm going to deploy a single change to, to the GitHub repository. In this case, I'm going to create a branch, have your test, oops, git branch. All right. So I am in a different branch than the dev environment. And I'm going to make a test fail on purpose. So I'm going to go to the unit testing and I'm going to modify the status code. So in this case, I'm going to create a commit, modify unit test on purpose. And I do git push. Sorry, git push origin and the name of my branch. So I can now create a pull request to my repository. That's what I'm going to do now. I'm going to push to the dev branch. I'm going to create a pull request. And we can see, it takes some time. Yeah, there it goes. The continuous integration workflow gets triggered. I'm going to create, to open a different tab here. I have defined 4 different workflows. In this game, the last one that is running is the one that got triggered with my pull request. It's going to check the continuous integration operations. It's going to check lint rules, TSLint rules, and the unit tests. While we wait for the workflow to finish, I'm going to show you some settings for this repository. I think they are only viewable from me, which I'm the owner of the repository. So in the environments, the GitHub environments, I have created 3 different environments: development, staging, and production. I'm using the environments feature from GitHub. And I have defined a simple rule here that, for example, this deployment, I only want to be triggered from the dev branch. That's it. Uh, and of course, the secrets, which is the AWS access key and AWS secret access key. For this example, I'm using the same AWS account. I'm deploying all the changes to the same AWS account. I have worked in other places where there are different AWS accounts for different environments. That's pretty neat. In this case, well, we can see that the continuous integration failed, and we're going to check why. This is the reason. Yeah, it was expecting. I wanted to return 2000, but it returned 200, which is correct. I just made it fail on purpose. So we can see the pull request that we cannot, or well, I could create a rule for the repository, but in this case, it's not recommended to merge the pull request. So I'm going to fix that quickly now. I'm going to create another commit, fix unit test, and I'm going to push. This commit is going to trigger another workflow, completely different workflow. So if we refresh the page, we can see that the previous pipeline failed, and there is a new one that is running currently. This pipeline should work, and we should be able to merge our pull request. Um, while we wait for this to complete, we can check another parts of the source codes. You can go to github.com/omenocal/hotel reservation API project, and you can download the full and the latest version of the code. You can see there are three active environments. I created this template using the serverless framework, using the AWS Node.js Typescript template. It created this README file. At the end of the README, you could see some screenshots of the deployment, since I think you will not have access to that since you are not a collaborator of this repository. It's basically what I already showed you. And yeah, maybe, yep, we can see that the pipeline succeeded, and the pull request is able to, or yeah, it's okay to merge the pull request. I'm going to go ahead and do that. This will deploy the changes to the development um, environment. We're going to see that later on. In the meantime, let's check the results of this previous workflow. We can see that all the tests succeeded. Um, we only have 5 tests, and all of them passed. So it was a great test. I'm going to pause the video now while we wait for the results of the environments. I'm going to deploy to the 3 environments, and we can see the outputs. Okay, so the deployments to the different environments have finished, and we have the outputs. In this case, for the production environment, we can see the 5 different endpoints that we have for that are exposed for our backend API. So let's check them out. So for example, we're going to post for a reservation. I already have a client here that will help me do that. Um, for example, I'm going to create a new reservation here. I'm going to add the application JSON content type. It's a post. Yeah, so the body here, for example, we have client ID, the room ID, start date, 0101. Yeah, we're going to create a new reservation, and we get the reservation ID here. So this is the first endpoint, the create. We're going to get this. We're going to get this reservation with the 123 room and client ID that I just created here. We can see the created date. It's 9 UTC time. It's 3 o'clock here. I'm 6 hour. There's a difference of 6 hours. Great. So that is the reservation that I just created in the post HTTP call. I'm going now to update here with a patch HTTP operation. I'm going to modify the room ID. just the room ID. 1, 2, 3, 4, 5, 6. It returns the same reservation ID, so I'm going to get again this reservation to check that the change was made successfully, and it was. The room ID was changed to 1, 2, 3, 4, 5, 6. I'm going to get all reservations. There should be other 2 or 3 besides this 1, 2, 3, 4, 5, 6 room ID. So we get all reservations. We have the 1, 2, 3, 4, 5, 6 from today. 1 and 2. Yeah, there was another one. Just the reservations in the system. I'm going to delete the last reservation from earlier. That is yesterday for me. I'm going to delete with the delete HTTP. It was okay, it was deleted okay, so I'm going to check if that's correct. I'm going to get all the reservations again. It should be return only one. The endpoint is called get all, reservation get all. Yep, get all with the reservation that I just created for this video, 1, 2, 3, 4, 5, 6. So this is the project running. I'm going to run some integration test real quickly. Integ test. I think this is, sorry, I don't remember what's the command, sorry. Integ test, okay, simpler. So this will run integration test using the AWS Lambda endpoint. So it's going to, yeah, all tests were passed successfully. One is skipped, is the create endpoint. I didn't want to create a reservation every time I run this integration test. You can see this is for the integration test. I have skipped this integration test. As you can see, I called the this is the development endpoint. I call the development endpoint no mock at all because this is directly to our system, to the development environment. I just expect the behavior of the AWS environment here. In this case, for example, I get a reservation here. I get all the reservations. This is the development environment again. I was testing previously with the production environment, and this is the update, the patch operation. So all operations are there. This is all the project I have created. I hope you like it. Sorry, it was really long. But yeah, thanks for watching.